Okay, welcome back to the second part of our third lecture of the week. um, as in the previous section, we are working on some unit conversion problems, and we'll do a few more and see how far we get. When I remember what I will hope that you're doing is that when I set up the problem, you can take that information and pause the video and then try working it out yourself, and then compare your answer to mine and how we get it, and hopefully you'll see get a better idea how to approach things like this. And let's see, last thing we did was volume, 18 cubic inches to cubic kilometers. We could also do a conversion involving area. Convert, say, 4,500 feet to, square feet to square meters. Say you want to buy a new groovy shag carpet for your house, and you've got a pretty big house at 4,500 square feet. And your brother-in-law says he can get you a really good deal on carpets, but he lives in Canada and he sells carpet by the square meter, not the square foot. So you have to convert from square feet to square meters so you can tell him how much you need. This, I will give you a hint before I tell you to pause. This is a conversion involving area. And you may notice that there are no sections labeled area here on the conversion factor sheet. You may be able to find conversion factors for area somewhere, but not here. And I don't think our textbook has them either. So what you're going to have to do is think of area as length units squared. We do that sometimes with volumes, length units to the third power, but with volume, there are also special units like liters and milliliters and gallons. With area, the only special area, or the only special unit I can think of for area that's used commonly would be acre, and that's about 57,000 square feet, or it's equivalent to a plot of land that's 240 feet on each side, a square plot. But for most units of area, it's just going to be length units to the second power. So that's how I would approach this conversion. And now you can pause the video and we'll come back and do it together in a minute. Okay, so if you're coming back now and you've either given up or you've got an answer and you want to compare it, we can try this together. We need a conversion that goes from feet to meters. And then if we can find the right conversion factor or conversion factors, we can then raise them to the second power, and we should be able to work everything out. So let's see what we find under length. So feet and meters, these are the two we really care about. Well, there's feet to centimeters. Oh, there's feet to meters right there. What do you know? 1 meter. And sometimes, you don't always use the things that are right next to each other, but you can compare, as long as the quantities are equal, you can compare any two of the entries in these equivalences. So we've got 1 meter is this many inches, which is also the same as this many feet. So you can compare meters to feet. 1 meter is equal to this many feet. So why not? 1 meter is 3.281 feet. Is that right? 3.281 feet. Okay, so that's what we're going to use. Okay, 4,500 square feet. That's the numerator. For our conversion factor, we're going to use linear units, and that will be between feet and meters. We want feet on the bottom, so it'll cancel with these feet. And we want meters on top, so that's what we'll end up with. And we have to square the conversion factor. Don't forget that. Because then by squaring the conversion factor, that makes this unit on the bottom square feet, so that it will cancel with this unit here. All right, square feet cancel. Meters squared, or square meters, give us the unit. And if we take 4,500 divided by 3.281, we get 1371.533069. Obviously, that's too many significant figures. You don't, and I should also probably mention that when you're writing answers down on tests or quizzes, you don't have to write the answer your calculator gives you out completely, like I've been doing. You can, if you want to, decide how many significant figures you should have and figure that out directly on the calculator and then just write down the final answer. That's fine too. In this case, 4,500, notice it has a decimal point. That means these zeros at the end count, and that's 4 significant figures. Meters to feet is a conversion between English and metric systems. So this number here is rounded off. 3.281 is also 4 significant figures. So this answer should have 4 significant figures. So we get 1371. Those can stay. Everything else has to go. The first number that we're dropping is a 5, which means the previous number has to go up by 1. So 1372 square meters is what we need. 1,372, that's 4 significant figures. So there you go. Okay, so that was interesting. We can also try, let's see. Oh, here's an interesting one. One atom of copper would have a mass of 1.0555 times 10 to the minus 4 Ag. And we want to convert it to pounds. Okay, so the first question is, what the hell is an Ag? Well, G as a mass, I said mass right here, in fact, clues you in that this is a metric unit. The G stands for grams if we're talking about mass, and then the A must be one of the metric prefixes. And sure enough, it's not one of the more common ones, but if you look at the table, there it is way down at the bottom, attograms. Okay, so actually, I'll let you take it from there, and you can pause the video, try to work it out, and we'll be back in a moment. And then you can restart the video and we'll compare results, okay? Okay, so if you've paused the video and you've tried it and we're coming back now, we can figure out how to work this out. I gave you a clue and then I told you that Ag stands for attograms. And we want to convert this mass to pounds. One thing you'll notice before we even do that is just how small single atoms are. An attogram is 10 to the minus 18 grams. That is decimal point 17 zeros and then a 1. That's an attogram. Decimal point 17 zeros and then a 1. And a single atom of copper is 1/10,000th of that. And so that's pretty small. 1 gram is about the mass of a standard size paperclip. So even a gram isn't a whole lot of mass. So when you have, what is it, 10 to the minus 22 grams is what this amounts to, and we'll figure that out on paper in a moment. That means that a single atom is extremely small. So you kind of appreciate it when you think about these magnitudes. Okay, so we're looking for some kind of conversion between metric masses and pounds. We've got attograms here, and that's not a very common unit, but it is a metric unit, and we can convert it to any other sort of unit involving grams just by manipulating the metric prefixes. So we're looking for conversions between some sort of grams, not necessarily attograms, but maybe milligrams or just grams or kilograms, and pounds. So let's see what we can do under mass. 1 pound, oh, there you go. 1 pound is 453.6 grams. So there you go right there. We can use that. Okay, so using that, what that means is we have to get from attograms to grams. Okay, so over here where it says 1 attogram is 10 to the minus 18 grams, or 1 atto unit, whatever the unit is equal to 10 to the minus 18 of that unit. Okay, that means we want attograms on the bottom, so it'll cancel with these attograms. And we want the number of grams associated with it on top. So now attograms will cancel, and we'll have grams as the unit. And now it's just a simple matter of using this equivalence for a conversion factor. And for that, that means that we need the grams on the bottom and the pounds on the top. Okay, so grams cancel. We have pounds as the unit, and we'll see what the number ends up being. Okay, 1.0555 times 10 to the minus 4. Was that? Times 10 raised to the minus 18. Okay, divided by 453.6. So we get 2.326940035 times 10 to the minus 25. It's important when you're working with calculators also just to be sure that you look for this at the end of the display. Some calculators display the times 10 raised to a power, even, it's even smaller than it is on this calculator. So be sure that you look for that and don't just write it down as 2.3269 blah, 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 and forget the 10 to the minus 25, because that's there. Okay, so that is our answer so far. As you might guess, that's too many significant figures. So we're going to have to find out how many we should have. 1.0555, that's 1, 2, 3, 4, 5. 5 significant figures. The conversion between grams and attograms is within the metric system, so both those numbers are infinite. But 1 pound to 453.6 grams, that is between English and metric systems, so that's rounded off. 4 significant figures is what we should have in the answer. That means 2, 3, 2, 6 can stay, but everything else has to go. First number we're dropping is a 9. That means that the previous digit has to go up by 1. So 2.327 times 10 to the minus 25. That is our final answer. And that is the weight of 1 atom of copper. So we're pretty familiar with what pounds are. I think of 10 to the minus 25 power of a pound. Really, really, really small. Okay, and another one, I think it may end up being the last one we can do in this segment, but an interesting one is dealing with densities. As I mentioned before, there are no conversion factors on this table for density. So I wanted to make sure to do at least one more density problem, because when you're dealing with something like that, you can't convert both units at the same time because we don't have the right conversion factors. For speed, if you want to go kilometers per hour to meters per second or something like that, then you can find conversions for speed right here where you can convert both units at the same time. But you can't do that with densities because there's no listing here for densities. All right, so last time we did a problem like this, we used the density of something that's very dense, osmium. the densest of all the chemical elements. This time, let's try using density of something that's not very dense, the density of air. Now, air is actually a mixture of gases, and you can get the density of air just by taking kind of a weighted average of the gases that are in the air. Air is mostly nitrogen, about 80% nitrogen, and about 20% oxygen, and tiny little percentages of other gases. So if you just basically take a weighted average of the density of nitrogen and oxygen, you can get something that's pretty close to the density of air at room temperature, say about 70 degrees Fahrenheit, and normal atmospheric pressure. If the temperature or the pressure change significantly from that, then the density of the air will also change because gases can expand or contract really easily. All right, so the density of air is 0.00128,628 grams per cubic centimeter, approximately. And so you can see that's a pretty small number. The density of osmium was 22.6 grams per cubic centimeter. And that's one of the characteristics of gases. They're not very dense. Okay, so we want to convert that to something that we might be able to relate to a little better. But since air is so sparse, let's say, or so not dense, we're going to need to have a fairly large volume of it in order to have an appreciable mass. If we did it pounds per cubic foot like we did with osmium, then you'd end up with a really small mass of the air as pounds per cubic foot because there's not very much of it in a cubic foot. So let's say convert it to pounds per cubic mile. Cubic mile should give us enough of a volume to have an appreciable amount of the air. And we'll see what that weighs. Okay, so what that means is you're going to have to convert grams to pounds first, and then come back and do cubic centimeters to cubic miles, which will be quite a challenge. So take your time, pause the video, try it, maybe try it again if you don't like the results and see what you get, and then you can start the video again and we'll compare our results. Okay, so you can pause the video. Okay, and if you're coming back, we will attempt this conversion. Now, first of all, let's look for conversions that can help us. We need to go grams to pounds, and then we need to go from cubic centimeters to cubic miles. That's going to be the hard part. Grams to pounds is going to be pretty easy because we just used that one a little while ago. 1 pound is 453.6 grams. Now, from cubic centimeters to cubic miles, that's a volume. And so if there's anything under volume that can help you, you could use that. And what I see is cubic centimeters to cubic inches. But that might be able to help us, actually. And cubic feet to cubic meters. That could help us, maybe. There, like I said, with many other, well, actually with any conversion, there's any number of different ways you can do it and get the right answer. How about just with linear, one-dimensional length units, though? We could always raise the conversion factors to the third power if we need to. We've got inches to centimeters. We want centimeters to miles. Centimeters to inches again. Feet to centimeters. Oh, we're getting closer. Centimeters, feet, kilometers to miles. Yeah, we're getting kind of. 1 mile is 5,280 feet. So if we can get from centimeters to feet, then we can go feet to miles. So that would probably be the shortest way to do it. So we have 1 foot is 30.5 centimeters, and 1 mile is 5,280 feet. And then we're going to have to cube those conversion factors when we actually use them. Because these are one-dimensional length units, and these are three-dimensional length units. All right, so we'll take our 0.0012868 grams. Since we are converting the two units separately, we're going to want to write this as grams over cubic centimeters explicitly, rather than grams / cubic centimeters. Okay, if we're converting the top unit first and the bottom unit later, then we're going to want to go to pounds. And we have 1 pound is equal to 453.6 grams. Grams we want on the bottom so that they'll cancel, and we want pounds on top because pounds per cubic mile are the units we're looking for. All right, so grams will cancel. We have pounds on top. I'm going to circle it because actually we've got the unit on top that we want. And then we can continue on and come back to the cubic centimeters. If we stopped and wrote down the answer now and multiplied the numbers out, we'd have pounds per cubic centimeter, which is a pretty weird unit because it mixes English and metric units together. If we just go back and convert the centimeters, though, we can convert centimeters to feet in one step. Okay, so we want centimeters on top, so they'll cancel with the centimeters on the bottom back here. And that will leave us with feet on the bottom. But don't forget, this is cubic centimeters back here. So once we've got the conversion between centimeters and feet, everything in that conversion factor has to be cubed. And the way you represent that is by writing the exponent 3 outside the parentheses. And just to remember or remind myself, I'm going to circle it and draw an arrow to the 30.5, so I don't forget to do that when I multiply it out. Okay, so this unit inside the parentheses is now cubic centimeters, which will cancel with cubic centimeters back there at the beginning. And we've got pounds per cubic foot now, if we stopped here, but we wanted pounds per cubic mile. We know that 1 mile is 5,280 feet. We want the feet on top and the 1 mile on the bottom. And remember, this is cubic feet. This is the hard part because the 3 is way up here and the feet is way down there. So that's why I circled this to remind me that it's there. This is cubic feet that we want to cancel out, which means this has to be cubic feet, which means everything else has to be cubed in order to keep the ratio true. So we just put the 3 outside the parentheses, and remember that it applies to everything inside, including the number. So now this is cubic feet in the numerator and cubic feet in the denominator, so they cancel each other out. Now we will have units of pounds per cubic mile if we multiply all of this out correctly. For the number, I would take 0.0012868 divided by, whoop, there we go, 453.6 equals that, times 30.5 to the 3rd power equals that, times 5280, whoops, I'm going to use parentheses around that, 5280 to the 3rd power equals this, whoops, that, 1.184305529 times 10 to the 10th. Okay, that's a pretty big number, actually. Not only long, but big. Okay, so that is our number of pounds per cubic mile. Before we look at anything else, let's consider significant figures. In the original number we had, the first two zeros don't count because they're zeros at the beginning of a number. They don't count for significant figures. But 128, 628, that's 6 significant figures. Pounds to grams is between English and metric, so that is a rounded off number. That's 4 significant figures. Centimeters to feet is between English and metric, and so that's rounded off. That's only 3 significant figures. 50 to 80 feet and miles, though, that's within the English system, so that's an exact number, so it's infinite. So 3 significant figures it is. So the 1, 1, and 8 can stay. Everything from the 4 on has to go. 4 is less than 5, so we don't have to change any of the numbers we're keeping. 1.18 times 10 to the 10th power pounds per cubic mile is how many pounds of oxygen there are in a cubic mile, or of air, sorry, that there are in a cubic mile. That's a pretty big number, actually. In fact, I hadn't worked this out before I did it right now, and actually it surprises me how big it is. Air isn't very heavy in small volumes, but it adds up. A cubic mile is a really big volume. So actually it probably shouldn't be surprising that it's a pretty big number. Okay, so that is a unit conversion that was pretty difficult. If you can handle that, then I think you're doing just fine. Otherwise, you should definitely get some more practice. There's more practice in the homework problems. You can go back and review some of the videos we've done, but I think that's really all that we have time for in the lectures. There's one more segment to this lecture coming, but we haven't really done anything about the scientific method yet, so I need to cover that. Okay? So I'll see you in part C.